Okay, uh, hello, welcome to my channel. This is problem number 4, continue part 2 of this problem. Okay, if you are watching if you're watching this is as your first video, this is the second part of the problem number 4. We will try to solve for the magnitude of the acceleration of the pin at the spiral path, and so far we were to obtain the relationship between theta and time in theta dot, and also theta double dot. Okay, in this part of the video, we will show you how to determine r dot, and r double dot. Okay, so firstly in r, the question already giving us the uh, expression of r equal to k theta, which is k is a positive real number. That means now r is depend on theta, okay, and theta is depend on time. So if we substitute the theta function that we found last video in here, we will get that theta theta as a function of time equal to alpha t squared divided by 2 plus pi over 3. Okay, then if we differentiate it, we will get that r dot theta equal to k theta dot, and then we substitute alpha t as theta dot. And theta double dot, we substitute theta double dot as alpha. So r double dot equal to k alpha. Okay, then we determine the t at theta equal to 3 pi over 6. Now, why we have to do this? Firstly, because the question was asked to determine the magnitude of acceleration of p when r reached theta equal to 3 pi over 6. So that means we know the angular position of the problem of the what the problem want to find. But what we don't know is what time it is that we get theta equal to 3 pi over 3 at what time. Because we if you look closely, every relation we describe is have a time included in, but there's no time in they don't tell the time information, so we have to find out by ourselves. So determine what time you need to sort theta to be this value. We then look back on the theta function of time. Then we substitute t equal to t1. Then we substitute theta t1 equal to 3 pi over 6. We then rearrange the equation and get t1 equal to plus minus square root pi over 3 alpha. Of course, we will not use a minus here because, well, it doesn't make sense if time is in minus. So next we determine each and every value shown here at t1. Okay, theta and r, position, velocity, and acceleration. Okay. Firstly, at theta position, obtain substitute to t1 in here. We get that we get that theta is equal to pi over 2. Substitute again in the function of theta dot. We then get theta dot at t1 equal to square root alpha pi over 3. Then theta double dot, since there's no t in this theta double dot, so the acceleration will be just alpha. Okay, so next we then determine r dot and r double dot. Okay, substitute t1 equal to substitute t equal to this value into r, and then we get that r at t1 equal to k pi over 2. The similar sense in r dot and r double dot. Okay, so they ask us to determine the magnitude of the acceleration. So we call out the acceleration vector, substitute what we know so far, and then rearrange it a little, simplified it, got ourselves this simplified version. Then a magnitude. So we uh, power the component by 2, summation together under square root, we get ourselves around 1.33 k alpha. Okay, now the important thing to see here, to take note here, is that first we have to uh, uh, find the relationship of the theta and r depending on time. Okay, so firstly, we know that the theta is um, will related by time because it's referred to angular speed. Okay, now the r, even though they give the equation of k theta, that means it dependent on theta, but it just this as disguise because the finally theta will depend on time. So it's safe to say that all depend on time, but it just happen the radius depend on theta first. But in any case, you have to find a relationship in r and theta, and if they give you the velocity or acceleration, try to integrate it back to get the position function, because that is the fundamental of how how you differentiate it and how you get more information. Okay, now that's it, guys. Thank you so much for watching, and we'll see you in the next problem of what it will be. Thank you.